Have you ever wondered if you can be offering a faster, less buggy application experience for your customers? With Raygun Application Performance Monitoring, you have all the information you need at your fingertips to find and fix errors and performance problems across your tech stack down to the line of code. Raygun makes it easy to monitor the impact of your performance improvements, quickly identify and resolve issues, and see how your code performs in the hands of your customers, saving you time, money, and sanity. I've personally used Raygun on my iOS apps, and when a user hits a crash, those crashes get centralized into one location. They get bucketed automatically. I'll get a call stack and an email with a line number where things were crashing. It felt to me that I got a gift for my customer in the form of a bug report that I could actually solve. Head over to raygun.com and try it out for yourself. That's RAYGUN.com for a free 14-day trial. I'm Scott Hansel, and this is another episode of Hansel Minutes. Today I'm talking with Avery Pennarun, the CEO at Tailscale. How are you?
Pretty good. How are you?
I am having a good time because I'm doing lots of research and I'm learning and Googling and searching and binging for information about my network. I've been talking about my network that I've been building on online for a while. We're all home, so why not upgrade the network? So I've got like a commercial grade network now with like a rack and the whole thing. I've got dual internet connectivities because I've had one provider go down, one provider not be reliable, and all the kids are on Zoom. And then I start hearing about Tailscale and how I need to not just think about my network hardware, but I need to just rethink networks in general.
Yeah, it's funny you say that because all my coworkers are just like you. They've been building these super fancy networks with multiple switches and stuff like that. And I've literally got an Airport Extreme from like 5+ years ago. It's like, this is pretty good. It has 802.11 AC. What's the problem?
Yeah. Someone said online, they were like, this is just like gear. You're just literally looking for an excuse to buy gear. You could have done this with, WRT or whatever, like default Netgear router and like some open source firmware.
Yeah, it's funny. I love all this stuff. I've run companies building Linux-based network appliance servers and stuff like that. I've patched the Linux kernel and written drivers. And when I come home, what I want to do is not any of that stuff. I want to sit and just have a router that actually works and never gives me trouble.
Mm-hmm. Well, as I've been out doing this and having fun, I've also been kind of low-key upgrading, my parents' router. I think we've all had that situation where we go to non-technical relative and fix their situation up. And I noticed that I'm getting a lot of people get double natted, where it's like they've got the router that they got from Comcast, and then they've got the router that I recommended, and they get themselves into a weird situation where stuff doesn't work. So they're double natted, and then they have to VPN into work. And then I have to figure out how to undo it all. Maybe we could back up and you could explain what I just said.
Sure. Double natting is actually, it's funny you bring it up because it's one of the things that I have a little bit of a pet peeve about complaining about double nat, because surprisingly, double nat is really not much worse than a single nat. Mm-hmm. Each time you go through a NAT, it changes your address from like your private internal subnet 192.168. something into whatever is on the other side. So if you've got a double NAT, you'll probably have a 192.168 on something on one side and a 192.168 on the other side. And then it goes through the next one and it has like some public IP address. But it turns out, and people blame that for their slowness a lot of the time, but it doesn't really make that much sense because it's, you're going to saturate the CPU on one of the devices, and then it'll go through and saturate the CPU on the other device. But it's not like twice as slow because the natting process doesn't take any time. It just takes a certain amount of CPU. So double NAT is roughly the same in terms of speed as a single NAT. What makes it unreliable is that routers generally have bugs. And so if you run things through two routers, then you have two sets of bugs and you're twice as likely to run into weird problems.
That is a really cool way to explain it. I also think that the proliferation of the double NAT is bad thing can go back to Xbox Live, where an Xbox would declare, how bad your NAT was. And then the one thing I care the most about after work is I want my NAT checkbox to be green on my Xbox to say, yes, you're prepared to successfully talk peer-to-peer with other people and play video games. And if it says it's bad, then that they were taking that NAT level indicator as a health indicator of their general network.
Right.
And that started the myth.
You're right. That sounds right. I've done tech support for an ISP, and it's sort of sat in on calls. And you're right. It is often Xbox people that do the most complaining about double NAT. And I think that does make sense because there's various different ways if you want to do a peer-to-peer connection to get your gaming friends' traffic back to you. There's different ways to open that external port back to your inside device. If you do it by hand with double NAT, you're going to have to do port forwarding twice, one at each of the NATs. If you do it automatically, it'll use UPnP, Universal Plug and Play, to automatically try to do that. But UPnP doesn't work with double NATs. It'll only open up one of the NATs, and then the other one will still block your traffic. So that's probably, I'm pretty sure Xbox uses UPnP pretty heavily. That's probably one of the reasons why it reports this as a problem, because it doesn't know how to get through this double NAT situation.
So then in the world of the Reddits and the forums and the kind of the blind leading the blind world, I apologize if that's an inappropriate ableist term. There's also people who say, put this in the DMZ. And what does that mean? Does that just say, just open the front door and unlock it completely and we'll just sit on the porch?
So DMZ is this, it of course comes from the military. So in between two countries that don't trust each other, they don't want to have a border right up against each other. So they define this sort of empty area where neither one is allowed to go. The original term DMZ was actually intended to be where you would put a public-facing web server for your company that is supposed to be accessible from the outside, but you still want to firewall everything except the web server port. But also, you don't want someone who breaks into the web server to be able to break into your private internal network. So the DMZ is where neither private devices nor public devices are allowed to tread. Nowadays, it's sort of lost its meaning. So if you go into your router settings, if you find a DMZ setting, what that does is it sort of tries to isolate this device into its own world. But it's kind of the opposite of a DMZ in that it sends all the traffic to that device. So it's sort of an extra militarized zone. What that does, though, is it means you don't have to set up any port forwarding by hand. You just let all the traffic flow. And when incoming traffic shows up and it's like the router is like, oh, I don't know who that's for, I'll just send it to this one. So it actually puts the device into this extra vulnerable situation where all the traffic is going to go hit that device.
Interesting. So it's not a classic move it out. It's just basically forward all the ports and, good luck.
Yeah, exactly. And it makes it easy because otherwise you have to guess which port number your video game is using and try to forward the packets through. And if you use a double NAT, of course, you have twice the problems because you have to forward the ports twice.
Mm-hmm. Okay, so double NAT, if it works, isn't as big of a deal as people say, and it's not a huge performance issue, although you do have a better chance to hit the union of bugs that are on both of your different brands of routers. But it does seem to bump into issues when folks use different, somewhat obscure or different corporate VPNs. Like a couple of my relatives are double natted and they haven't said a thing to me in a year, but another one has some obscure VPN I've never heard of and it just can't work. Why would a corporate VPN be unable to traverse a double natted system?
So that is almost certainly exactly the thing I just said about you running into the combination of two bugs. So one of those two routers is probably blocking the corporate VPN. And when you have two routers, you have twice the chance of running into one. Almost always the VPN affected by that is IPsec. IPsec is this is getting a little bit technical. But it is neither UDP nor TCP. It is its own IP protocol that got allocated back in the 1990s. And the problem with the internet generally is that there's all these devices that expect everything is going to be either UDP or TCP. And if it's IPsec, they just don't know what to do. So there's a bunch of really strange problems that occur because of that. But it's very common to get a router that they forgot to implement IPsec correctly. And sure enough, it fails. One of the worst problems with the IPsec protocol is that it doesn't understand the concept of port numbers. So where you have I can have say a web server listening on port 80 and a different web server listening on port 8000. And I can dial to either port 80 or port 8000 and I get a different web server. IPsec does not have that ability. So when combined with NAT, what you get, for example, what if you have two people at home on two different computers IPsecing into the same remote server, right? They will both be NATed to the same public IP address, connecting to the same remote public IP address. when the packet comes back from that remote public IP address, we have to map that back to the private address of the device it's supposed to be addressed to inside the network. Unfortunately, you have two different devices that are trying to talk to the same endpoint, and there's no port numbers anymore. Normally, NAT would change the port number on the way through, so it can look up that port number and change it back on the way back. Without a port number, you can only have one IPsec session open at a time from a given NAT firewall to the given remote address. And that is usually some combination of things like that make IPsec not work. But it's probably not caused by double NAT. It's probably caused by one of the two NATs.
And that sounds like just the kind of like obscure thing that a relative would have where it's like, oh, well, we both work at the same company and I don't know why, but only one of us can be on the VPN at one time.
Yeah, or you've got your corporate laptop and you've got your phone both on the VPN and one of them works and the other one doesn't work. And it's just totally random.
Ugh, what a mess. So then getting to Tailscale, the company that you founded based on the popular open source WireGuard package, let's talk about the stack here and help me understand, is VPN, and I may say this wrong, so bear with me, but is VPN a vote of no confidence against like the internet itself? It's just like, no, it shouldn't have been done this way, so we will spackle over the top of it. We'll putty over a better thing, and we'll use that instead.
So this is a huge, huge topic that I have many opinions about. And you can talk about it in a lot of different ways. I would start with just the idea that one giant network that everybody is connected to is not necessarily the thing that anybody wanted, right? We kind of thought we wanted it. This is all like back in the 1970s, 80s, and 90s when this was coming up. It seemed like the coolest thing in the world to like, let's connect all the computers to a single global network so that everybody can talk to everybody. And I think it's only in the last few years that we started realizing as a society that that's not necessarily the best idea. When you have a giant community that includes everyone, then some of those people are going to be very bad people. And it's only a tiny, tiny percentage. But if that tiny, tiny percentage of people has complete access to everyone, it becomes a really serious security problem, right? And the bigger the internet gets, the bigger the security problem becomes. And so this idea of let's put every computer just out there on the internet, people have been questioning that for a long time, and it just gets more serious every year. So firewalls were invented back, I can't remember. I did some research. I believe in the 1990s, like surprisingly recently, firewalls actually started coming into effect. And that it entirely because we didn't want our private devices to be exposed to everybody. And a VPN is just kind of the extension of that idea. In the past, we all used to go to a single office and every physical machine would be physically in that office. And so instead of needing a VPN, we had a physical private network where we could just trust everybody that was on that network. As things have gone more and more remote, especially in the last year or so, we now find that the physical private network doesn't really help us that much. We kind of just want to virtually have a small group of friends that we can trust. And I don't think that is giving up. I think it's a fundamental part of human nature that smaller communities can be more healthy and trust each other more.
Mm-hmm. It seems also that like both in the cloud space on the server side and then more in the home, that the rise of software-based networking is showing us that maybe we need to worry less about physical networking. Like we would physically separate people now and say, he's on this switch and she's on that router and I'm going to wire things this way and that way. We can really hide all that. We can abstract away all that now. Like, is software-based networking the future?
So I would say yes. And it's not because we can abstract away the physical network. I think the physical network was a very nice abstraction where you say, like, if you're allowed into my office and you can plug into an Ethernet port in my office, then I can trust your device. It was always really convenient, but it was never entirely true, right? I think this all started to crack. I remember very clearly the day when Edward Snowden made his dump of documents about the different kinds of attacks the US government had been making on different companies. And there was one in particular where there's this post-it note that says encryption added and removed here. And it was about how the NSA had infiltrated a particular company as posing as the people who were installing the private fiber connections between this company's data centers. And they installed taps on these private fiber lines. So this company believed that because it was their own private data centers and their own private fiber between the data centers, that it was perfectly okay to not encrypt the traffic and to just trust the traffic that was going over these lines because it was completely owned by the company. And it turned out the NSA was able to read every single packet going over these lines. And that just, this was before that came out. I had heard this as an idea, right? And I wrote it off as a conspiracy theory. Like, how much work would you have to go through to run your own fiber installation company just so you could infiltrate some company that wasn't even doing anything wrong, that was in your own country, right? And it's just shocking. But it turns out it was for real, right? And so companies now who are really concerned about security know that they simply cannot trust physical network links. Like, anything could happen. And so it doesn't make sense to ever send an unencrypted packet over a physical link. Now, of course, that's companies. Individuals have fewer threat models generally, except because the internet has been getting so big. Now, even if you're not a very valuable target, there's somebody out there who has written some general purpose malware who is going to try to get into your machine and, ransomware your files or something like that.
Yeah.
Right?
I mean, war driving is still a thing. Like, I remember when it was like at its height and people would drive around and you'd have some rando in a Honda Civic parked out front of your house. You're like, what's that guy doing on his laptop? And he's looking for open SSIDs to poke around. And kids used to like look for a printer and then print, like, I've hacked your, I've hacked your printer, when all they did was find an open Wi-Fi network, print something, and then, do like a little, all your bases belong to us maneuver.
Yeah, I think there's actually a lot of good things that can come from us not trusting physical network infrastructure. Because, for example, it was nice back in the very early days of Wi-Fi. A lot of people would just start a Wi-Fi access point and not encrypt it because they felt like, oh, look, if I'm sharing my internet with other people, what's the big deal? And I think a lot of people would like to share their internet with other people. I have lots of internet at home. I would be perfectly happy if my next door neighbors need, or a guest can just walk in, borrow my internet for a few minutes and leave. The reason I can't do that is only because there are so many people out there now who will come in and exactly what you say, try to print to my printer, try to cast some stuff to my Apple TV. It's unfortunate that the two things are tied together. The idea of like using my link and using my stuff, right? Those are two completely different things. My stuff should not be automatically granting you access to stuff just because you physically are in my neighborhood.
And now those of us like myself who are, somewhat understanding of networks, that we can go and set our houses up with, quote unquote gear, but not deeply understanding in the details, may have a sense of false security as we put this gear in, but we haven't really thought about that relationship between the physical and the virtual and the user.
Yeah, encrypted Wi-Fi is actually surprisingly good. The very first attempts at encrypted Wi-Fi obviously failed spectacularly. It's kind of funny. The encryption, they knew they were going to fail. They named it WEP, which stands for Wired Equivalent Privacy. And I just love that name because the people who designed it are like, look, this is as good as the protection you get from saying, if you can plug into my Ethernet, you get access to everything, right? And that is not very good security. It is well understood, and it was well understood at the time, that someone could walk into an office that usually has an unlocked front door and then plug something into the Ethernet port and have access to everything. And that is the level of encryption they put into the first level of Wi-Fi, because they're like, look, it needs to be as good as wired. What's the problem? And it turned out it was not as good as people were expecting. What they built after that, WPA and WPA2, actually turned out to be quite good. There's been a few little around the edges, some cracks, and there's a WPA3 that's in the works right now, but WPA2 is actually very good encryption. What makes me sad mostly is the idea that I can't safely share my internet without knowing who you are. And I kind of, it makes me sad. It's possible to set up guest networks and stuff like that, but it's complicated. Most people don't bother doing it. And then once you're on my network, say, you visit my office and I give you or my cafe and I give you the wireless access code. Now I have to trust you 100%. It's like, it goes from, I don't trust anybody to, okay, I trust you a little bit because you're physically here. Now, like, everything's wide open, right? You enter my network, now you can print to my printer, now you can access my Apple TV. It's kind of weird, right?
You know how your ops team keeps a pile of scripts and wiki documents explaining how to perform those routine and emergency tasks that keep your applications running? They might call them runbooks or playbooks. Our friends at Octopus Deploy were thinking, DevOps is about collaboration. So doesn't it make sense for runbooks to be automated from the same place as deployments? Well, Octopus Deploy is now the first deployment tool with native runbook support. The best thing is your runbooks can share configuration settings and automation steps with your deployments. Find out more at octopus.com. Are those of us who are doing this gear at home, who are listening to this podcast, who are thinking about separating their IoT devices and their light bulb from their work computer on separate SSIDs, separate VLANs, separate entirely different networks, is that the kinds of thinking that we should be applying?
I think that's an extremely good idea. IoT devices are sort of famously insecure to start with because most of the people writing the software for these devices are quite often external contractors who would do a one-time contract to get the thing shipped and out the door. And you will never get software updates for many of these devices. Sometimes the company goes out of business and it will never be updated again. That's just sort of, there are movements to try to make sure that devices will guaranteed get software updates for a certain amount of time, or that companies will get punished if they don't provide software updates. That stuff I don't think is really going to work because the most likely outcome is these companies making the IoT devices will declare bankruptcy and then too bad for your warranty, right? They will always be insecure. It's just that, computers, as the internet gets bigger and computers get smaller and smaller and cheaper and easier to build, they will always be insecure. And so the best thing you can do is isolate them from each other so that when your light bulb goes bananas, it can't go infecting all of your other light bulbs, or so that you can control who on the internet can come in and talk to your faulty light bulb, so that even if your light bulb has 1 million security holes, only you are allowed to exploit the security holes in your own light bulb.
Mm-hmm. So now I understand that Tailscale is all the way from enterprise, large scale, like, giant company and all kinds of cool support, but also all the way down to like regular in home server hobbyists, enthusiasts, personal devices. You can have up to 100 devices for free. At what point can I start thinking about it as being a solution to some of these issues where I could go and change subnets and route things around my house? Could I apply Tailscale to my home to solve problems like this?
You could. The idea, actually, the name Tailscale, it came before the product, and that the term Tailscale is the opposite of internet scale. It's all about this idea that if you have a small number of people that you can trust and give them access only to specific things that you trust them to access, then you don't need to be as secure. It's a way of like getting past all of these concerns about security that the world has sort of gotten into. And in order to do that, of course, we have to use security technology to make it work. One of the things that Tailscale does that makes it so that your device, it doesn't really matter where it physically is. It can be plugged into a trusted or an untrusted network. And you get this level of trust when it tries to talk to your other devices that it's allowed to talk to. The part that Tailscale does not do is help you isolate your IoT light bulbs if they are on the same physical network. That's something where you can't do that from a node point of view. You would have to do that from a routing point of view. Although we do have some of our corporate customers who then install Tailscale, use that for communicating between all of their corporate devices in a trusted way. And then they disable at the router level all communication between devices that is not through Tailscale.
That's interesting. Which gets to my original kind of question about, is it a vote of no confidence against one way of thinking? It really inverts our thinking completely.
Yeah, exactly. It's all about don't trust the physical network, or rather, change it so you don't need to trust the physical network. And then it's perfectly okay that your physical network is less secure.
Mm-hmm. And this making all the things that I know about trustable can go all the way to my iOS devices, my Android devices. And it also, is it true even cloud instances? So I could have a VM I'm running in Azure or AWS, and that could be as if it's sitting next to me. It can be in my subnet.
Exactly. So Tailscale is kind of it's a pretty weird VPN. We call it a VPN partly because corporate customers completely relate to the idea of a VPN.
Well, people think they know what they are, and then they Google for VPN, and then they find you, and then they start exploring the product.
Yeah, but it's kind of a weird VPN because there's no VPN server in Tailscale. You just put like a little Tailscale package on every device or computer or mobile phone or iPad or whatever that you want to connect to, and then Tailscale generates these point-to-point connections directly between devices that are encrypted. Because of that, it doesn't really matter where those devices physically are. We have a little bit of magic in there that makes it so they can locate each other, whether they're going through a NAT or a double NAT like we were talking about earlier, or if they're in the cloud behind firewalls, or in people's houses or in cafes. You can have your phone in a cafe talking back to your laptop that you left at home. And it just has the same address and host name and services that it had when they were physically next to each other on the same Wi-Fi.
Mm-hmm. I remember when I first started at Microsoft, we would only be able to VPN into Redmond. So then I would be like in New York working for a client, and I would bounce around the country. So like you could start feeling the speed of light because you're in a hotel in New York, you VPN into Redmond, which then goes back across the country to a client in New York. When you're feet away from someone, you end up having to cross the country and back just to talk to a device.
Yeah, absolutely. I worked in New York for several years, and we had exactly that problem where the head office was down in California, and all my traffic would get sent back all the way to California, even if I was trying to access a server that was also in New York, just so that it could go through all the security systems and stuff like that.
Mm-hmm. So that's the traditional hub and spoke VPN where you're talking to a gateway. We've all heard of VPN gateways. So the way WireGuard and Tailscale above it work isn't that.
Right. Yeah, it's what's called a mesh network. We stay away from the word mesh network in our marketing because, of course, nobody knows what a mesh network is. Most people know what a VPN is, so we stick to like simpler terminology like that. But it's it is quite hard to explain. The way the overall system works is we have only one central point, a central service that we call the coordination server. And so every device on your network that needs to be able to talk to other devices on your network drop their public key and their current location on the internet into this coordination server. And the coordination server then shares that location information and public key information back to each of the other devices on your personal network. Those devices then take all of the responsibility for initiating a connection to other devices on your network for the direct links. So you never have a latency increase on the data path.
Mm-hmm. This might be a dumb question, but those are sometimes the most educational ones. This is apples and apples and carburetors, but how does Tailscale and the way that it thinks about networks relate to things like BitTorrent, where they're massively meshed or massively peer-to-peer?
That's a great question, actually. I'm often inspired by tools like BitTorrent, or even sometimes how malware works and viruses work. I say sometimes like viruses have the best software installation process. You never have any tech support calls from somebody who had trouble installing a virus, right? And that's not true of a lot of commercial software. So there's actually techniques you can learn from all of these things. BitTorrent, I think, is pretty great. One of the things that it does is this peer-to-peer connection. It would be impossible to operate BitTorrent if all of your giant downloads had to go through a central server in the cloud somewhere, right? The whole point of BitTorrent is to avoid the need for that. One of the things that makes BitTorrent kind of finicky to get working and a little bit flaky once it does get working. Like, for example, you go to download something and sometimes it doesn't download, or sometimes it gets started and quits halfway through, or sometimes it can't. It says it's there, but it can't make any connections. Is that it doesn't have this concept of a central coordinator like we do. And that's partly because they want to protect against different kinds of political attacks, shutting them down. So there's legitimate reasons to build a 100% completely decentralized systems like that. Tailscale, because it's intended for you to use for your own stuff, not necessarily to create this huge distributed network with 0 points of failure, we can afford to have this one single coordination point. And it's a little hard to explain, but there's a part of distributed systems theory that says if you can just get away with having a single coordination point, building the rest of a distributed system is extremely easy, right? So we have that one single coordination point. We just use it as little as we possibly can. We just have this one point that then makes the rest of the system really easy to design. It gives you, as the person who runs the network, a central point of control over exactly what each of your devices is allowed to do or not do.
So does not having a coordination server that's a single point of failure in a distributed system would allow it to avoid being the bottleneck from a performance perspective, but it doesn't prevent it from being an issue from a that thing goes down and the network is broken perspective?
Exactly. It only sends short messages occasionally between devices when those devices move around on the physical network. And so if the coordination server goes away for a little while, in the worst case, we have some downtime or something, it doesn't really matter because all the devices remember what the situation was most recently. And as long as not too many things change, it'll keep on going.
Interesting. Okay, so it's a concierge, and he can take a break, but the hotel keeps running.
That's a great way of thinking about it. Yeah,
I like that. So, if I were, or one of our listeners were, to think about a practice run to go and create a Tailscale network, is the scenario of my kid wants to be on Minecraft and I don't want to open a port a good one? Should I recommend to my 15-year-old and his 15-year-old friend to plug Tailscale on both of their sides and make a free network for them to play Minecraft on?
Yeah, that's a great example. Actually, I don't know why, but Minecraft is one of the most common examples I hear from people who want to use Tailscale at home, specifically Minecraft. And it's a little strange. We actually started playing Minecraft at work just so we could get a better understanding of why our customers like Minecraft so much. But yeah, it does work great. In fact, all you have to do is you set up a Minecraft server anywhere in your home or in the cloud somewhere. Ideally, you do not open any port forwards or anything like that. You make sure it doesn't have a public IP address. If you're running it in the cloud, you run it behind some kind of firewall and you just block all the ports. And then you also install the little Tailscale package on that machine, whether it's a Windows machine or a Linux machine. You log in as your user account, either like a gmail.com or hotmail.com or your corporate domain, or outlook.com, whatever. And then from the device you want to access it from, you also log into Tailscale with the same account. And then those devices are just going to be connected to each other automatically. There's no extra setup. You just install Tailscale on both machines. You log in as the same user on both machines. And now both machines can see each other directly. If you want to share with your friends, we have a new feature that is just about to leave the beta testing phase that a bunch of people have signed up for. We call it node sharing. That allows you to take your Minecraft server, which could be physically located anywhere and might even move around. So maybe it's on your laptop, for example, and share that with people with other accounts than just your own. So you invite them to just your Minecraft server, and then that Minecraft server will appear as if it's on their personal private network. And so if it's on your laptop, for example, you carry your laptop around. Every time your laptop is open, that Minecraft server is available to your friends, no matter where they might be.
That would be cool. Now, is there any way that someone might, who is writing the server, make an assumption and get confused, like if a host name changes or they think, you're moving them at one layer in the 7 layers and they write their code in such a way that they're confused, that they're not where they expect they are, have a bit of an out-of-body experience?
So we try to make it as easy as possible. So the Tailscale link assigns you a static IP address that's in this special IP range 100.64/10. We call it 100.x.x.x. It's not quite accurate because the 100.0 through 63 are not included. But we give you an extra IP address that's in addition to the private IP address that is assigned on whatever network you're on. So as long as the software you're using always connects to the 100.x IP address, that address is going to stay the same no matter where the devices physically move around in the world.
Very cool. So as long as it binds to that, it's going to just expect that and see that everywhere, and it'll just work.
Exactly.
Very cool. And it'll just work is what we've been hearing about Tailscale today. I appreciate you chatting with me today.
Thanks for inviting me. This has been exciting.
Yeah, we've been talking with Avery Pennarun, CEO of Tailscale. You can check him out at tailscale.com. This has been another episode of Hansel Minutes, and we'll see you again next week.